Problem number 3 on Spring 2015 gives you a definite integral, tangent squared x, secant squared x dx, evaluated from 0 to pi over 4. And all it says is evaluate that integral. So let's go ahead, let's take a look and see what we can figure out. So the first thing I notice is that there is a tangent squared and a secant squared. I noticed that the secant squared has a positive power. Now this corresponds to chapter 7.2 or like 7.3. And this would be when you're dealing with different combinations of trig integrals. So the one thing I note is that whenever secant is a positive power, when I'm dealing with tangents and secants, my substitution that I want to use is u equals tangent and du equals secant squared x dx. The reason I want to use this is if secant is a even power, I can always get a secant squared term out of it so that I can make this substitution work. Any other additional secant squared terms can always be converted using the trig identity, which I'll go ahead and write down 2 just in case we need to use it. 1 plus tan squared x equals secant squared x. So I know that if I have any additional secants, I can always just convert them into this and I can still integrate the function. If secant is an odd power, though, that kind of leaves me a little bit high and dry. I can't really deal with that secant squared term because I'll always have one secant to a first power left over. And that doesn't fit into this equation. And there's no way to really deal with it. So what I would have to use is I would have to use the u equals secant du equals secant tangent substitution instead. But in this case, because secant is an even power, it fits the bill perfectly, and we can go ahead and actually solve it. So if I go ahead and plug in my u and my du, I don't need to convert anything in this case because this whole term right here is du, and this is just going to be u squared. So I end up just getting u squared du. When I go through the integral, I end up getting u cubed over 3, evaluated from 0 to pi over 4. And before I evaluate it, I always want to plug back in for x. So I end up getting tan cubed x over 3 from 0 to pi over 4. Now, all I have to do is just go ahead and evaluate tangent pi over 4 and 0. So what I end up getting is I end up getting tan cubed of pi over 4 all over 3 minus tan cubed of 0 over 3. And to figure out what that is, I think of my unit circle. Tangent of 0, that's 0, because tangent is sine over cosine at a value of 0 radians. Sine is 0, cosine is 1. So this is 0. At pi over 4, sine and cosine are equal, which means that tangent is 1. So this is tangent cubed of pi over 4, which is just 1 cubed. So that ends up just being 1/3 as my final answer. And if I look at the answer key, for form B, letter D is 1/3. So the answer is just letter D.
The Teaching Center, UF's Learning Resource Center.